A shop gives each of 1,000 people a voucher, and 28 people use their voucher. The shop now gives each of 16,500 people a voucher, so it's the same voucher. And we need to work out how many of these 16,500 people are expected to use the voucher. So the first thing we can do is, it's 28 people out of 1,000. So 28 out of 1,000 multiplied by 16,500 is 462. And that is the answer. Now there is a part B to this question. So the part B is a bit different, not related to the part A. So it says, in a class activity, all of the 15 students wear hats. 7 students wear red hats, 6 wear green hats, 2 students wear white hats. One of those students is picked at random. Find the probability that this student wears the red hat. So we handle this question first before moving on to 2. So the first thing we can do is, one of the students is picked at random, so that student could be wearing a red or a green or a white hat. So we are only interested in the red. The probability that this student who wears the red hat would be the total number of red hats, that's 7, out of the total number of students, 7 out of 15. And that's the answer for this question. Okay, so for part 2, it says that 2 of the students are then picked at random, and we need to show that the probability that these 2 students wear red hats of the same color is 37 out of 105. So what we do is, the same color, isn't it? So same color could be both red, they could be both green, or they could be both white. So notice the or, we use an or. So then we find the probability of red and red and add it to green and green and add it to white and white. So the probability of the 2 reds is 7 out of 15, total 7 red out of 15, multiplied by, if you pick the first one, remaining would be 6 out of 14, and then plus green is 6 out of 15, 6 green, so 6 out of 15 is the first. Then if you have one person has won the green, the next person, the probability is green. The next person, next hat is green, the probability the next hat is green would be 5 out of 14, because one goes off, one is off, so 14. And similarly we do it with the white. There are only 2 white, so plus 2 out of 15 times 1 out of 14, and when you multiply this all and add them all up, you are going to get 37 out of 105. So you actually get 74 out of 210. You have to divide this by 2 and you get 37 out of 105, and that's the answer, 37, and it's what they've given, so it's correct. So there is a part C or part 3, yeah. So this part, it says you have to do a bit more work here. So it says, in a class activity, all the 15 students wear hats, 7 students wear red hats, 6 wear green hats, and 2 wear white hats. So the continuation of the same problem. So you have the same conditions, that 7 red and 6 green and 2 white. And then they say that 3 students are picked at random. So they've increased the number of students they're picking now. So 3 of the 15 students are picked at random, and we need to find the probability that at least 2 of these 3 students wear red hats. So there is an at least here, which means that at least 2 means it cannot be 1, it has to be 2 or more. So 3 students are picked, so red hat, so you can have we can have 2 red hats or 3 red hats. So it's either 2 or 3. You cannot have 1 red hat because at least 2. So then how do we go ahead with that? So 2 red hats would mean the third hat is either a green or a white. So it's either 2 red and 1 green, or 2 red and 1 white, or those are the only 2 conditions with 2 red, and then with 3 red there's only one possibility, all 3 are red, so 3 are. So now we have to find the probabilities for each of these, and we have to add them up. Now there is a thing here, like if there is 2 red and 1 green, there comes a situation of arrangement, like which is coming first. So when you have 2 red and 1 green, you have a red and a green, or a red and green and a red, and a green and a red and a red. So that can be done in 3 ways. And then so we can work out what the probability will be. But before that, we move on to this condition with 2 red and 1 white. So in similar way, you can have a red red white, a red white red, and a white red and red. And then for 3R, it's just 3 red, 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 and red. So if we write down the probability in this case, so it'll be 3 times, because there are 3 ways it can be done. So 3 times. So red is 7 out of 15. The second red is 6 out of 14. And the third green, is 6 out of 13, because you will still have all the 6. So 6 out of 13. And you would add it to, similarly, I think you can do the rest. So similarly, you will have to work out what is 2 red and 1 white. So 2 red would again mean 7 out of 15 times 6 out of 14, and then multiplied by 1 white. So the probability there is 2 out of 13. So there are 3 ways, so we are multiplying it by 3, and then 3 red will simply be 7 out of 15 times 6 out of 14 times 5 out of 13. And if we work that out, we should get 1218 out of 2730. Now we have to simplify this. So if I were to divide it by 6 first, so if I could divide by 6, then what would I get? You see, 6 times I would get 203. 6 times 2 is 12. 0 and 6 times 3 is 18. 6 times 4 is 24. 33, 5. So this is dividing by 6. Now this can be divided one more time. We can, or two more times. So we pick a 203 is not a prime. It looks like a prime number ending in 3, but it is not. It's not divisible by 3, but it is divisible by 7 and 29 and so on. So 203, if you were to divide it by 7, and you could then divide 455 also by 7, you would get 63. So 7 times 9 is 63, and 7 times 6 is 42, 35. 7 times 5. So 29 out of 65. And that is the final answer, 29 out of 65.